Okay, so now I want us to look at this finance question from the Mpumalanga question paper. Okay, let's look at this finance question. Let's work on it very fast. So look at what we are given. We are given Jane deposit RX into an investment account. How long will it take for the value of the investment to double if the interest rate is 5.4% per annum compounded monthly? Annual. So you know what I'm going to do. So we are going to deposit RX. We don't know the amount. So let's let that to be X into an investment account. So this X is it will be my P, the principal amount, which is the amount that we start with. How long will it take for the value of the investment to double? So we need the accumulated amount to be 2X to be double that X. And then the rate, which is I, 5.4% per annum, is compounded monthly. So since it's compounded monthly, okay, okay, it's fine. Let's work on this on the other side. I'm just gonna write all the given information, then we'll take it from there. Okay, let's check what we are given here. To answer this 6.1, they said that Jane deposit, we start with the principal amount of X and we need the accumulated to be double that X. Okay, so you are given the interest rate, which is 5.4% compounded monthly. So the 5.4%, we need to convert that. Remember, we're going to say 5.4 divided by 100 and see what we get on the calculator. So we're going to take the 5.4, divide that guy by 100. What is this equals to? 0.054. So my interest rate is 0.054. 54. So now remember, this is a compound interest, and the formula for compound interest is equals to A is equals to P 1 plus I to the power N. So we are looking for the value of N, right? So let's do the substitution. Let's substitute everything on this equation. A is 2X. It's equal to P. That's X into 1 plus the interest of that 0.054. Remember, this is compound. You don't have to say I over 12. You just substitute the 0.54 and everything to the power N. Okay, so to work out of this problem, what I'm going to do, I need to get rid of that X. I can divide this side by X, divide that side by X, because I can't have two variables on my formula. I need to have the one variable that I'm looking for. So let's get rid of X and write this as 2. It's equals to, then we're going to add whatever that is inside the bracket, okay? So when we add the brackets, it's going to be 1 plus 0.054. And what is that equals to? This gives us 1.054. So I'm going to write that as 1.054. So this will be 1.054. That's what we have inside the bracket. And I'm going to use the logs. Okay, so you see, when I have this, I know that there are different ways that we can make an subject of the formula using logs. So in most cases, you guys say the subject of the formula, we can make the exponent, which is n, the subject of the formula. Then this will be the log of whatever that is the base, is going to be the base on the log. So this will be the log of 1.054, and then the 2 comes there. So you can just do it like that, but let me show you another way that you can do this. First thing first, you can log both sides. This has to do with the loss of log. I can say log of that 2, it's equal to the log of that 1.054 to the power n. So there's a rule here, the rule for logs. There's a rule that says if I have the log of a to the power n, I can bring the n in front and write this as n the log a. So this is the rule that I'm going to apply to solve that problem. So I'm going to say this is the log of 2. It's equal to, bring the n in front. Then we have the log of 1.054 to the power n. Oh, I'm sorry, the n is in front now. Then we are looking for n. I can divide both sides by n and say n is equal to the log 2 over the log of that 1.054. So these two guys, they should give us the same answer. Let's try and test if we get the same answer in both of these equations. Right. The log 2 on top over the log 1.054, close the bracket. This gives us 13.18 if we round it off. Let's go and test that one. The log of the base, which is 1.054, and this is 2. They should give us the same answer. See, 1.318. So it's up to you which one you prefer. You can just move from here, go to that one, or you can just continue with applying the log. Let's impress the marker. Let's show the marker that we know these things. Right? So therefore, n it's equal to 1 point, or it was 1, 3 point, what was the answer? 3.18 if we round it up. So this is 3.18. Yeah. So, and then you can just leave your answer like that, 1.318. That is n. Let's go to the next question. I'm looking forward to working on the next question. So the next question says that Chavo starts a printing company. So I think you guys can see how I attack this question. I analyze my statement first, make sure that I have everything, I understand everything on the statement. So Tavo starts a printing company. He needs to borrow. I see the word borrow. This has to do with loan. Okay, so this will be present value. It won't be future. This will be present value. Right. So we know the formula for present value. We'll talk about that. For a startup cost, he can make equal monthly payment. So the 3,300, that's my X. 3,300. What amount can Tabo borrow? So we are looking for what? What amount? The present value. We are looking for P. What amount can Tabo borrow if he invests if the interest rate on the loan, we are given the interest to be 12%, and the 12% is compounded monthly. So the interest rate will be 12. You divide that by 100, which gives us 0.12. Okay, so when you substitute that on the formula, don't forget to say this is compounded monthly, divide by 12. We'll definitely talk about that. So therefore, your I will be that 0.12 divided by 12. Right. And then what about N? N, it's also compounded monthly. So this will be 5 years times 12. What is that equals to? We'll definitely work on that on the next question. You see, I've already know everything that I have, which formula I need to do. I just have to go to the formula and substitute everything on that formula. So the loan is granted over 5 years. So we need to calculate the present value. Let's go and work on this. First thing first, I'll definitely give you guys the data that we're working on with NEP. So this guy, we are looking for P. And then the formula for P, it's X into 1 minus, you don't have to stress about memorizing the formula because they give you the formula in the formula sheet and everything is divided by I. So look at this. I have X, monthly equal payment was given as 3,300, and then we said the interest rate will be 0.12, which is 12% divided by 100, but this is compounded monthly. Therefore, we have N to be 5 times 12. What is that equal to? I'll definitely confirm that now. So I think it's 60. 5 times 12, that's 60. Okay. Right. So I think now I have everything. I have I have N, and then I can just do the substitution. You see? Simple. What will be the present value? To answer this question, let's go and read the statement. Tower starts a printing company, needs to borrow money for a startup cost. He can make equal payments. So, guys, you have two types of formulas. Né? Let me explain this because it's very important that we don't do guesswork. You have two types of formulas, the one for the present value, the one for the future, which is x into 1 plus I to the power n minus 1, right? Everything divided by I. So when do we use the P? When do we use the F? So the present value, when you see the word loan, present value. When you see the word invest, future value, you use the F1. So we only use these two these two formulas if you have the installment. If you are making a monthly installment, what is an installment? Is the money that you pay every month, a fixed amount. You can't say installment, this month you pay 150, next month is 250, the other month you pay 500. It should be the same amount every month. I hope you guys understand that part. So the reason this one it was compounded, we use the compound formula, is that this is just it's an investment, but we are not making any monthly installment. You understand? So that's why we use that formula. Okay, so I think now we no longer focusing on the question. We are going into too much details, but if you want to understand this, I think we do have a theory behind finance. Just search on my YouTube and on my videos, check the theory behind future, the theory behind investment questions. Okay, let me just do my substitution and see what is P equals to. So P is equal to X, that's 3,300. Then we have 1 minus into 1 plus 0.12 divided by 12. Everything to the power negative 60. Close the bracket. Let's divide that by the interest rate. So the interest rate is 0.12 divided by 12. Therefore, this is another issue. Punching this on the calculator, I need you to move in with me. Yeah, it's fine. You can move in with me. I have a lot of space in my room. You can move in with me. So this will be 1 minus, please move with me. 1 minus into 1 plus. I also need you to punch this on the calculator so that you can get it correctly. So this will be 12. And then close the bracket to the power negative 60. Oh, shucks. To the power negative 60. And then close the bracket. Everything is divided by 0.12 over 12. What is that equals to? So this gives us 14,800. Then is that 14,000 or is that 148,000? Okay, so it makes sense. 148,351 and 63 cents if we round that off. You see, you need to learn how to punch this on the calculator so that you can get the correct answer. So R, we said 14,800 and it's 148,000, 351.63 if we round it off. And that's it for that question. Simple, easy maths, Simple, easy maths. Okay, so when I look at this, let's go back here. Let's talk about the mark allocation. Okay, when I look at the mark allocation, you see for this I, you'll definitely get a mark for that correct substitution. And then for converting N, there's also a mark for that. And then if they check that everything you substituted on this is correct, there's another mark. Then they'll give you a mark for the final answer. Okay. Moving to the next one. Next question. A group of investors consider, you see, now I see the word investing. But it's fine. Let's read the question and see what is the question say. A group of investors consider investing a fund that promises growth at a rate of 5% compounded calculate the effective annual percentage rate of the growth promised. So if you don't know what to do, write your I effective formula down. You can copy that from the question paper. Né? This is equals to 1 plus I to the power n. Right. So when I write this on my side, I need to make the I effective subject of the formula. Okay. Then I need to say, okay, the only thing that we have here is this is 5% and it's compounded quarterly. So if it's 5%, this will be 5 divided by 100, which will give you 0.05. You take that 0.5, you divide by 4. When they say compounded quarterly, divide that by 4. Let's go and answer this question. Okay, I'm sorry if I'm moving fast. 2.3. Okay, this is for 2.3. So we are saying that I effective plus 1 is equals to 1 plus I to the n. Okay, I know that I just don't remember the formula if it's y. Okay, I think it's y over n. Something like this, right? I don't remember how they write this. Is it n to the power n? Let me just confirm this first. I'm just gonna open a past paper and see if we have a formula for I effective. Okay, I just confirmed this. The formula is correct, guys. It should be like this. Né? Therefore, I'm going to say I effective is equals to, this will be 1 plus my I over n to the power n. Let's subtract 1. So let's write that data. They say I is 5%. Okay, so I'm going to divide that by 100, which gives me 0.05. And then therefore, they said this is compounded what? This is compounded quarterly. We're going to take the 0.05. It's fine. We'll divide that by n. Eh? So let's just do the substitution. I effective is equals to 1 plus 0.05. This is compounded quarterly. Close the bracket. Then n is just 4. Then we subtract 1. So the only thing that you need to do is to punch that on the calculator. I think finance is easy, né? As long as you understand the statement. So this is 1 plus 0.05 over 4. Remember, compounded quarterly, we divide by 4. And this will be to the power 4. So the I effective, it's 1,05555 something. But remember, if I say the I effective is equals to that 0, it was it 0 or 1,0? Okay, we got, let me see, 1 plus 0.05 over 4 to the power 4. We forgot to minus 1 there. Minus 1 equals to 0.05. So it's 0.05, 0.05, 0 something something. Né? I don't remember, but it's fine. I'll show you how to do the final answer. I effective will be with, you take whatever that you have there on the calculator, multiply that by 100. So when you multiply that by 100, the answer is 5.09%. So the I effective, that's 5.09%. Simple. You're done. That's it. Next question. See, we are moving. Okay, I think this is the last question, right? Yes, this is the last question. So Sarah is 18 years old and wish to accumulate 10,000. Oh, that's not 10,000. A lot of zeros. 10 million by the month before a 50. But you see this type of question, I think we need to pay attention on this one. So Sarah is 18 years old. He wished to accumulate. So this is my final amount. So this is the future value. The future value that we need is 10 million. Okay, by the month before her 50th birthday. So this person is 18 and is going to invest money until he reaches 50. So what will be my N? That's what you need to ask yourself. You find the difference between these years. So if this person is trying to reach 50, to invest until he's 50, and now he's 18 years, we subtract the two, we get N to be 32. So N is 32. So my N is going to invest this money for 32 years. And now she deposit equal monthly payments into the account, and I is given as 15%. If you say 15%, you're going to divide that by 100, which gives us 0.15%. Okay, 0.15. The first payment starts on her 18th birthday and the last payment 50th birthday. Okay. So I think we are missing something here. Look at this, compounded monthly. So if it's compounded monthly, remember the I should be divided by 12. Calculate the monthly installment, which is X, that Sarah will make. So you need to ask yourself, do I have monthly installment? Yes. What are those monthly installment for? That's for investment. So if it's an investment, that's a future value. Then you write the formula for future value down. You write the formula for future value down. So this will be 2.4. So F is equals to X into 1 plus I to the power N minus 1, and everything is divided by I. So let's just do the data. If you still remember the statement, he's trying to get 10 million, and then if he's trying to get 10 million, the interest rate, it was 15%, and then we take the 15, we divide by 100, the answer gives us 0.15. But remember, therefore the I is that 0.15 compounded monthly. Okay, let's talk about N. Okay, so this is my interest rate. I need to talk about N. The number of terms, that 32 years, which is compounded monthly. You multiply that by 12. What do you get? I think this is a very big number. Eh? Okay, where's my calculator? Okay, so we're going to say 32 times 12. This gives us 384. So that will be 384. That's N. So let's do the substitution and see how to find X. So this will be where there's F, I'm going to sub in that value. Yeah? So where there's X, I put, where there's F, we put 10 million. This is equal to X, which is what we are looking for, into 1 plus I, which is 0.15 compounded monthly, to the power N, which is 384. So please don't substitute 32. Compounded monthly. Don't forget to also divide that 0.15 by 12. Then you subtract 1. Close the bracket. Everything is divided by I, which is 0.15 over 12. So you know what I'm going to do? You see this part of the equation. I'm going to punch this part on the calculator and see what I get. So the answer that I can get, I'm going to, or let's do this. Let me make this easy for you to understand. Okay, I want to teach you something that my math teacher used to do. And he said that if you do this, he called me by my name and he said, you know, if you do this, there's no way you can get this question wrong. Because most of the time I used to go to him and say, I've been trying to work this thing out, but I keep on getting the wrong value of X. And he was like, do it like this. Avoid rounding off. Do it and say 10,000 or 10 million. Multiply that 10 million by the 0.15 over 12. Then equate this to X into that 1 plus 0.15 over 12. to the power 384 minus 1. And then he was like, when you have it like this, remember, let me just rewrite the equation here. It's 10 million, which is multiplied by 0.15 over 12. And then this is equal to x. 1 plus 0.15, everything divided by 12 to the power 384 minus 1. He was like, divide now both sides by that. 1 plus 0.15 over 12, 384 minus 1. And if you do this, there's no way you're going to get your x wrong, because most of the time the issue is rounding off. So I'm going to divide this by 1 plus 0.15 over 12, and then everything to the power 384 minus 1. And please, when you punch this on the calculator, you need to be very careful. So this 2 cancels, and then now we can solve for x. So whatever answer that we get when we do that fraction, it will be x. So let's go and put that. I know this is a mess, but look at what I'm going to do. 10 million, and then open the bracket. This is multiplied by 0.15 over 12. Then close the bracket. You see, easy. Everything on the bracket. Open the big bracket. Then I have 1 plus 0.15. Also try and see if you get this correct. Also try and practice to put this on the calculator. 384. Then I'm going to, oh, the 384 is on top. You see, already making mistakes. 384, 384. Then we minus 1. Then that's when you can close the bracket. When you punch this on the calculator, this person has to pay 1,068.85 every month. So that's what he needs to pay to get that 10 million. You see, easy. So therefore, x is equals to 10,068.85. You see, therefore that's your answer. This is what the person has to pay to get that 10 million. I think this was the last question, and this is where we stop for this question. You see, the one from the Mpumalanga. This is where it stops.